Okay, continuing from that particular point, we can actually say it is giving me that. So what you can do is you can also want to present like percentages, because these are like just raw value. So which percentage do you want? If you say I wanted the total by, so that this is by 100 by column, so you just put CO there, and when you multiply, it gives you the frequency, which is the top number, and the bottom number is called the column percent. So in the end, it gives you the hundreds at that particular moment. So it's the same, only that you have now calculated the frequency and the percentages, and this is actually the command that you actually use to do that calculation. So take note of that, and after that you can be able now to run the other values. So you can actually say 106, then you check the percentages, it's again significant, and then the other one is by the region. So you can take the region, and then you can actually see that all values are significant at the inferential level. So this is the Pearson chi-square. It is used to actually measure the significance association between two variables, which is independent and dependent variable. Then thereafter, when you do this, you can now run the model, which is called the logit. So you can say TVW multiplied by, first of all, let me just take V025, V106, and V and the region. Let me just do it like that. And then when you run the model, these are the values that you can actually have. So you can actually see that the region at this level, it is 0 point something, 0.024, very small, and is insignificant, whereby this one is V102, it is significant. Why am I using logit? It's because it is a binary value, and logit means log it. So these ones, we assume them as probabilities. We assume that probability. So when presenting them, we present them as probabilities. So what I want you to do is, you can go on YouTube and say annotate logit regression output in Stata, and then you should be able to look at how they are interpreting and what these figures mean in a model. And when you do this like this, it means that I have taken these ones as concentrated variables. But if I want to check what could be the inside, then I put the I dots in front here, the I dots and the I dots, like that, so that I can look at what is it that could be inside. So on this one, after putting the I dots, you can actually see that igundonetsa ababa, igundonetsa 2 mwani balibepo, and the value yake ikonisa join. So these ones, if you can tab 2, if you can tab like V025, like that one, you can see the 2 is urban and 1 is rural. So what it means at this point is, this particular 2, it means that you are only showing results for urban compared to the results for rural compared to urban. The urban, which is silent, we call it as a reference category, is a reference category. So when you have got 2 point something like this, it is significant. It means that when interpreting this, you can actually say those people that were in the rural had a negative effect in watching TV compared to their urban counterpart who were at a unit of 1, and this is significant at 1%. Okay, you can repeat, you can recall that one so that you can understand what I meant. Now similarly, at this particular point, if you can tab V106, you can actually see that 0 is no education, 1 is primary, 2, 3 secondary. So if you can come to this data, you can actually see that it has kept the other one 0, which is the reference category. So it means that these ones were 0.57 with primary school are more likely to watch TV compared to those colleagues with no education, significant at 1%. Similarly, those that were with primary school, they even increased their likelihoodness of watching the TV by a factor of 1.7 compared to their colleagues with no education, significant at this particular percent, at 1%. Now, those with tertiary education, they increased even watching TV by 3.22, significant at more likely compared to those with no education, significant at 1%. Can you see the way it is? Now, even watching TV, those ones with Muslims and higher were not watching TV, had a negative behavior, had a reduced behavior of watching TV compared to their Catholic counterpart who are at 1. Similarly, those Protestants, they had a slight way of watching TVs by a factor of 0.16 compared to the Catholics who were at 1. So this is actually how we actually can be able to do. But you can see for the Muslim, it is not significant at this particular point because we use the P values to actually determine as to whether the value is significant or not. Now, this model can change if we can control here. If we can control here, if we can say no constant, meaning no constant. So we can rerun the model and then see that once we say no constant, it means that all variables are significant and even the direction of the signs they have changed. So when do we use no constant? When we don't want to have our values are controlled by unknown values, we actually use the no cons. So that's the most important part that can be looked at. So you can be able using the same. Let me remove this. You can be able to use the same. You can say probit. You can learn the probit. So the results could be like could come in this particular way. So I want you to make a comparison between probit and the logit. How are they different? And using the same, you can be able to use logistic. Okay, this is another regression model. So you can actually see that when I did logistic, the things they have changed. Instead of representing the coefficients, it is giving me the odds ratios. The odds ratio. So an odds ratio is just the let's take this one. Let's take this one. Let's take this value. I should copy this. Okay, and I should be able to come down here and say dimension exponential or display exponential of this one. Okay, and then I enter. It is giving me 0.422222, etc. Now I want to check where is this, not in the probability, but this can be in the logit. Let's see whether we have that. Okay, now in short, maybe translatory processes here has been quite different, but one thing that you must take note is that exponential, it is when you take exponential of something, it means that a coefficient, a beta, when you exponent a beta, you actually get an odds ratio. Now odds ratios, it actually explains the values between 0 and less than 0. So this one is a negative value because it is point. This one is a positive, 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 negative, negative. So that's the way an exponential, an odds ratio is used. Let me pause a little bit and continue.